Good afternoon. I'm François Bidet, Vice President of Business Development for Aptar CSP Technologies. The purpose of my presentation today will be to show how you can protect probiotics and microbiome formulations using active packaging solutions. Aptar CSP Technology is part of the Aptar Group. Our core competence is to be a material science specialist delivering innovative, highly engineered active packaging solutions. Our headquarters is located in Auburn, Alabama in the US. And every year, CSP is shipping more than 1 billion components from its 5 manufacturing plants located in the US, France, and in China. These products are supported by more than 500 worldwide patents. We are active in many areas like pharmaceutical, medical diagnostics, probiotics, and food safety. Our active packaging solutions are based on what we call the three-phase Activ-Polymer. So what is it? The three-phase Activ-Polymer is composed of 3 components. A majority polymer, which is having as a base structural component, which could be polypropylene or polyethylene. A minority polymer, which is not miscible with the first polymer. So by trying to mixing the two together, it's like mixing oil and water. So it's creating small channels where we can place a particle, which is the absorbing agent. What you can see on the right, you see a microscopic figuration of this active polymer. So the blue part actually is polypropylene, and it's creating channels. The channels are depending on the minority polymer and the proportion of the minority polymer. By having a bigger channel or smaller channel, you can control the gas diffusion through this channel. And what you can see in orange, this teeny part are 4 angstrom molecular sieve absorbing material. So with the active polymer, we can absorb or release gases. We can absorb moisture, we can absorb oxygen, formaldehyde, any VOC basically, or we can release aromas. We can release biocide or carbon dioxide. One thing also is, it's not a surface treatment. We are active on the thickness, and we can load up to 69% of active compounds. What is good is also that we can control the desired kinetics and adapt to the manufacturing and storage conditions. So you can choose between a slow moisture uptake or quick uptake. Here you've got 4 different curves, which is the same formulation, basically the same active compounds with a different minority polymer. So we can select the appropriate one depending on your manufacturing condition, on the product, and the storage that you want to obtain. Same for the oxygen. You can tailor how fast you want the oxygen to be reduced. What is important also to understand is the use of the 3-phase active polymer requires a tight seal environment. So gas or moisture transmission has to be reviewed. Focus on cells associated with the package, and the amount of 3-phase material required will depend on how tight is the environment. So basically, you need a tight sealed environment, a package, which could be a container or which could be a flexible packaging sealed. You need 3-phase active polymer technology. And like that, we will be able to have a total solution system, controlling the transmission rate and controlling the inner quantity of moisture, oxygen, or any VOC inside. So how can we apply this active polymer? There's this technology on several platforms. So the active polymer could be injected in molded parts or in vials or in bottles. It could be also extruded as a film that could be inserted in pouches, stick packs, or blisters. thermoforming, blow molding, and hot melt solutions are in development phase, and they should be available in the near future. So let's have a look on what the people are using. Major probiotic brands are using the Aptar CSP active packaging solutions. As you can see on the picture, the first use was to have a vial, and this is what I will present now. What we call the active vial is using what we call a two-shot injection process. First, an inner sleeve is injected with the Activ-Polymer, and in the same press with the same mold, we are over-injecting the cap and the body of the container in PPE or HDPE. The flip-top cap is closed in the mold, allowing a moisture-tight seal. Similar processes could be used also with to manufacture screw-top bottles. So what you can see on the picture on the right is the inner sleeve caps with the inner sleeve of Activ-Polymer. The capsules of probiotics which are in the vials are very well protected and will not be in contact with moisture before usage. If you take some example of protection, here you can see two different vials, a 64 ml vial and a 110 ml vial. So here we have calculated the functional life in terms of months. So you can see that we can protect the environment during more than 3 years, 36 months. So it means that the probiotics which will be packed in this vial will not see moisture or limited quantity of moisture, because we can guarantee the level of average below 10% during these 3 years. What is also important for the patient is the use life. So what is use life? I mean, protection between the first caps that your patient will take and the last one. So it could be 90 days of opening and closing. So when you take a capsule, the level of residual humidity inside the vial will increase to 50% or more if you are in the ICH4 area, like China or part of China. And after closing the vial, it will take 4 minutes to go back down to 5% residual humidity. So like that, we can guarantee that the first probiotic capsule will be kept as well as the last one. We've done several studies, and in this study, which was done by US labs, we have compared the CSP active vials with Activ-Blisters with two conditions, 25 degrees C, 60% RH, and 30 degrees C, 65% RH. And we compare these two conditions with Activ and the vial. So you can see that the water activity is going down very quickly with the active vial. So it means that for the strains and the stability of the strains, you've got better potency and you keep the strains alive longer time. So in this case, you can see the comparison with the two different formats, and basically the probiotic formulation are remaining stable, and you will have a decrease within the alu probiotics. Activ-Polymer could be also molded in any shape and could be integrated in devices like the X-Straw, which is a drug delivery device developed for infant and elderly people which have difficulties to swallow, or like the Bormanelli three-phase reconstitution cap, which is widely used for probiotics powder formulation, especially in Italy. So this molded part are integrated in the device. It can absorb moisture, oxygen, odors, and we can guarantee very tight dimensional tolerances. In this slide, you can see Activ-Polymer used to maintain the stability of probiotic oil drops. In the test made by GLAC, and they have placed a molded tablet in probiotic formulation resuspended into sunflower oil. With the Activ-Polymer, the probiotics strains are stable. Without the Activ-Polymer, the strain potency is falling down after 16 weeks. As mentioned previously, the Activ-Polymer could be extruded as a film, and the film could be inserted in blister. The film is added by its staking process to the aluminum backfoil. We will create an active headspace protection as we will remove moisture and oxygen from the headspace. This solution avoids complex extra packaging processes, and by moving from cold form to thermoform, it will reduce the footprint by 40 to 50% smaller, and it will increase the compliance because you will be able to see the capsules inside the packaging. So in medical experimentation, the addition of the active film in blisters is reducing and stabilizing the water activity very quickly. When you look at the strain stability, the Activ-Blister is maintaining the number of CFU at an appropriate level, avoiding to increase the initial quantity of probiotic CFU placed in the capsules at the manufacturing. And I will finish my data with an example of a probiotic contained in stick pack. So this study was made by GLAC also, and compared the CSP active film with no film at ambient condition. So basically what we have looked here is the water activity. So you can see with a smaller film, the water activity is going down. So it's 50% less than the reference after 8 weeks. And if you increase the size of the film, but you can also increase the thickness in order to have more absorption capacity, you have a better result also on the water activity. So when you look at the strain stability, the results are confirmed because you can see that this is in log depletion. So what you can see here is the reference product is going down very quickly. And with the active film, of course, bigger you are, better protection you've got, but it will maintain the strains in good quality up to the use by the patient. So in conclusion, microbiome formulations are sensitive to moisture and potentially to oxygen. The Aptar CSP active packaging solution will allow a better stability and extended shelf life of microbiome formulation. You can support the development of your formulation packaging with the Accelerate Development Program. Thank you for your attention, and I'm available for questions now or later by email. Thank you.